Sets are another type of data structure, and these are used for storing lots of items together, typically used when you want to compare sets to other sets of data. We'll go through all the different main comparisons you might use. I think this will become clear in a couple of the challenges later why these can be really useful. So, for example, to output the entirety of a set, it's just a simple print like we've done in the past. You'll notice that in some ways they look like a dictionary, but remember with the dictionary, the squiggly brackets, we had keys and items linked together with a colon. Now we've just got the values or the data separated by commas. So it looks like a list, but with the dictionary squiggly brackets, and this is referred to as a set. So I can output my set. I can do a lot of the sort of common things. So I could do add to. So for example, so I could do my set dot add, and I could add I don't know, an orange. So then when I run it, you can see there's a orange in there as well. Now, if I set it on wrap text, just so we can see it a bit clearer down here. Now, if I wanted to remove, I could do my set dot remove, and I could do banana. And now you can see there's only apple, cherry, and orange. So that's removing. One thing that you will probably find a little bit confusing, until we understand why sets are used sometimes, is if I try and add something that already exists again, so I'll try and add orange for a second time, I don't have two oranges in there. So sets can only contain unique values. So if it can't have duplicate values in a set, you need to use a different data structure if you want duplicate values, because these are used for storing things for comparisons, usually with other sets or other data structures. So let's go through some of these examples, and then you might start to understand why they can be useful. But truly, I don't think we're going to get this completely until we start using them in a couple of challenges. So we could do a simple true or false. So you can check if things are in a set. So I could do check if Apple, and then use the membership operators again. So just like lists and everything else, we can still do arguments like this. I'm going to change the sets to be something that's a little bit different, just so we can see some comparisons. So for example, let's have these. So I'm just going to copy and paste these in. Just delete these. So we've got two sets here, X and Y. So X is your apple, banana, and cherry, and Y is Google, Microsoft, and Apple. So obviously different types of data, but we have a duplicate here, and I've done that on purpose. So if, for example, I then say I want to output the difference between the sets, I pick a starting set. So I'm going to say like X, for example, and I'm going to do difference, and then in brackets I'm going to say Y. So if I run that, my spelling difference. There we go. So if I run that, you can see that it now says cherry and banana, because it's saying what is the difference within X when you compare it to Y. So the only difference is the items cherry and banana, because apple are obviously the same. So you can do these, you can combine two sets, and you will see that the output is in the format of another set. So you get a set as an output when comparing or combining two sets. So dot difference is one that you can do. You can actually remove the items. So if you do dot difference and underscore update, let me move that out here. Yeah, so if you do x.difference underscore update y, what that's doing is that's actually doing the difference thing that we just looked at before, but now because you've put in the underscore update, it's actually not just accessing it, it's updating x based on the differences. So if I go back and look at x afterwards, you can see that apple actually no longer exists in my set. So that's a way of updating. You can do an intersection as well. So if I get rid of that, and I'll say, you shouldn't use variables like this, but it's only to teach you the skills. So if I do z equals x dot intersection, I'll check my spelling this time, and y, and then let's print z out so you can see what the result is. You can see this is a tuple as a result, and it's got one item in it because it's looking at where these two lists intersect. So if, for example, two lists, these two sets. So if, for example, I put cherry here, when I run it, apple and cherry have come through because they are the two areas that these two sets intersect. So they've both got apple in and they've both got cherry in. You can see if things are subsets of each other. That's quite interesting. So if, for example, let me change these to be something else. So a subset, I'll just change those. So a subset is when this, for example, y is a subset of x because x contains a, b, and c. So this is a set, but it's also a subset of this larger set up here because every item in set y exists in set x, but y is smaller, hence it being a subset. So you can do, we'll have z equaling x dot is subset of y. And when you run it, this will equal true or false. Y is a subset of x. So I've done it the wrong way around. So y is a subset of x. And it's true. But as you saw with it being false, x is not a subset of y. Y doesn't even have enough values in for x to be a subset of y. So you can check if things are subsets of each other. You can do two others. So we can do, well, there's probably more, but I'll just think of the ones that I've used in the past. So you can do a symmetric difference. So I could have x dot symmetric difference of y. So this will remove, this will create a set, not remove, this will create a set which contains all items from both sets, but not the ones that appear in both. So this will basically get rid of the duplicates and see what else is left. So when I run it, so you can see the only things that exist in both but are not duplicates. So for example, if I put one in here, because it looks like all of these have come from X, so I'm going to put Z in here. When I run it, you've got Z, F, E, and D, because they are all the things from both combined that aren't duplicated across. So they're the symmetrical differences or the joined differences. And then you can also just do a simple union. I've probably missed some others out, but you get the idea. So these are for the scenario, so union will join them together, but obviously get rid of the duplicates. So sets are really useful when you want to store data and you're doing a program where a big part of your program is comparing data or analyzing data across. Putting the data in sets is probably the right idea because of how many powerful tools you've got to compare data between multiple sets. So that's sets. It's another data structure. It took me a long while to find use cases for it, depending on the type of challenges you're doing. But some of the activities I put would require a set, or it will certainly be easier if you use a set to achieve some of the goals.